All right, in this video, we're going to look at what are called logarithms. So a logarithm is kind of like an exponential type equation. It's really an exponential equation in disguise. So if we're given something like log base 5 of 125, all right, the answer to this is going to be 3. All right, and that's because 5 to the third power is equal to 125. Right? So whatever number here, whatever number you have here, this is your base. Right? Just like in an exponential statement, the base is the number that you are raising to the exponent, but these two numbers are switched. Okay, so it's when you're asking a logarithm question, when you're asked to evaluate a logarithm, what you're doing is you're really just solving for the exponent that makes that statement true. All right, so it was 5 to what power is equal to 125. That's how you do logarithms. They're just another way of writing little exponential sentences like this. Uh, so the general formula for a logarithm statement, I'll go ahead and give you that. It is log base a of some number is equal to x, and then its counterpart in the little exponential world, all right, it would be a to this power is equal to that. You're going to see in a little while that these two things, logarithms and exponentials, are just inverses of each other. All right, just like quadratics and square roots are inverses of each other. Let's go ahead and do some more of these logarithm statements because that's what you're going to be doing, is just evaluating statements like this. So if I give you log base 3 of 81, so all we're asking here is 3 raised to some power is equal to 81. So it's what power do I have to put here in order for this statement to be true? All right, that's going to be the fourth power. 3 to the fourth will give you 81. So log base 3 of 81 is 4. If I have log, I'll change my base here, log base 4 of 64. You don't have to put it in parentheses, but I've gotten to the point where I almost always use parentheses for logarithm statements. This just means 4 to some power will equal 64. So I've got to figure out what I need to raise 4 to the power of to get 64. Well, 4 times 4 is 16, and then times another 4, this equals 64. So 4 to the third power is equal to 64. Therefore, log base 4 of 64 is equal to 3. I'll do one that's a little harder to see. So these were all nice and whole numbers. This one is going to be log base 4. So it's 4 to some power is equal to 1 over 16. So 4 is my base. 4 raised to some exponent needs to equal 1 over 16. All right, the answer to this is going to be negative 2. 4 to the second will give you 16. And then because it's like a division statement, that just means my exponent needs to be negative. And this is one of those properties of exponents. If you raise something to a negative power, it just flips it into the denominator. So log base 4 of 116 is negative 2. All right, this one, log base 36 of 6. So here I'm saying, what do I need to raise 36 to? What power do I have to put on the 36 in order to get 6 back as my answer? Well, the square root of 36 is equal to 6. So it's like I need to do a square root right here, which is the same as a fractional exponent. 36 to the 1/2 power will give you 6. So log base 36 of 6 is 1/2. So you might want to have a calculator handy when you're playing with some of these, just so that you can test these little exponential statements so that you can figure out what the answer is over here. All right, this one is kind of a special one. Log base 20 of 1. All right, so this one would be 20 raised to what power is equal to 1. Hopefully by now you've grown accustomed to something like this. Anything to the 0 power is equal to 1. So log base 20 of 1 is 0. So I'm searching for the exponent that I have to raise 20 to so that I get 1 back as my answer. Now this is actually going to be true no matter what the base is, because 5 to the 0 is equal to 1, 2 to the 0 is equal to 1. So in fact, log, and no matter what your base is, log base anything of the number 1 will always equal 0. All right, this is one of those special relations that you'll want to memorize. Anytime you're taking the log of 1, you're going to get 0 as your answer. Another one that's kind of special would be log base 7 of 7. All right, this is going to equal 1 because if you raise 7 to the first power, you get 7 back as your answer. All right, and that's going to hold true for all numbers again. Log base anything of that same base is always going to equal 1. All right, these two are kind of special because they're always true no matter what your base is. So it's worth memorizing. All right, these are all pretty straightforward. I'm going to look at one that is not as straightforward. All right, this one I'm going to look at log base 8 of 32. All right, so I need to write an exponential equation here that represents this so that I can figure out what my answer is. So this is going to be 8 to some power is equal to 32. All right. You'll see here it's not going to be a nice number. 8 to the first power would equal 8. 8 to the second power would equal 64. So it's going to be somewhere in between 1 and 2. But we can take each of these and rewrite them as a power of 2 to figure out what x is. 2 to the third power is equal to 8, so I'll just replace the 8 with the 2 to the third power. And I can express 32 as a power of 2. It would be 2 to the fifth power. Power to a power, you'll multiply the exponents. 2 to the 3x is equal to 2 to the fifth. All right, and now you can equate these two exponents since the bases are the same. You've got 3x is equal to 5. Therefore, x is equal to 5/3. All right, that's what I have to raise the number 8 to in order to get 32 back as an answer. So log base 8 of 32 is 5/3. All right, that's it for this video. I'll look at one other thing in the next video.